previous explanation we have ended up to unit of rate of reaction, and now moving ahead, I'm going to discuss factor affecting the rate of reaction. Factor affecting rate of reaction. Factors that are affecting the rate of reaction uh, are firstly the physical state of the reactant. First one is physical physical state of reactant. Talking about the physical state of reactant, it may be either solid, liquid, or gaseous. The rate of reaction depend upon the physical state in the manner as it would be maximum for the gaseous state. In liquid it will be little bit less, and it would be least for the solid state. In it means in case of solid reactant the rate of reaction will be less, and in case of gaseous reactant the rate of reaction would be more. um, if we will we will try to understand the reason behind this. It is very simple. It depends upon intermolecular force. As the intermolecular force between the molecules in reactant decreases, then their easiness to move randomly increases. It means randomness of particle increases, and when randomness of the particle increases, then ultimately the rate of the reaction increases. So, in the gaseous state, the particles are more free to move due to less intermolecular force of attraction, and hence it has the highest rate of reaction in comparison to other state. Coming about the next factor, and that next factor is the size of the particle. Size of particle. But in case if reactant is solid, in case if reactant is solid, it means this factor will be applicable only when the reactant which is taken is in the solid state. So what we can say about this factor, it is just like as rate of reaction is inversely proportional to the size of particle. Larger the size of particle, lesser would be the rate of reaction. Next, third factor, that is surface area of the reactant. Surface area of reactant. This is also in case of solid reactant. In case of solid reactant. Um, and here rate of reaction is directly proportional to the surface area. Larger the surface area of the reactant, faster would be the rate of the reaction. Coming about the next factor, fourth one, chemical nature of reactant. Different reactant has different bond number varies in different reactant, as well as bond energy varies. So as the different reactant have different bond number and bond energy, so for various type of reactant the reaction would vary. It would be not same for every type of reactant. It depends upon the number of bond as well as its bond energy. Moving ahead towards the next factor, and that next factor is pressure. If the reactant uh, which is taken is in the solid or liquid state. If the reactant is solid or liquid state, then the rate of reaction doesn't depend upon pressure over here. In the case of solid and liquid reactant, pressure doesn't affect the rate of the reaction. But if the reactant are gaseous, then pressure affects the rate of reaction, and over here rate of reaction is directly proportional to pressure applied. If the reaction is involving the gaseous reactant, then only it depends upon the pressure. Otherwise, if the reactant is solid or liquid, then in this case the rate of reaction doesn't depend upon the pressure. Next one, and the most important factor that affects the rate of reaction, is the concentration of reactant. Concentration of reactant, and here rate of reaction is directly proportional to concentration of reactant. I am going to discuss this factor in little bit more detail. All the factor which we have discussed above is not as much important as this one, so we have to discuss this factor in detail. So let's move ahead. We will discuss dependence of rate of reaction on concentration of reactant. I am going to discuss this factor in much more detail. Um, at the given temperature in a particular reaction, the rate of reaction depends upon the concentration of the one or the other reactant given in that reaction, or it also depends upon the concentration of product. I mean to say, if the temperature is constant, there is a given temperature, then at that given temperature, rate of reaction depends on concentration of either of reactant or concentration of product. So here we have to understand one expression that is known as rate law, a very much important expression, rate law. Rate law, it is an experimental expression which show dependence of rate of reaction on concentration of reactant. So rate law is nothing. Firstly, it is an experimental expression. This expression is derived experimentally, which show how the rate of reaction is dependent upon the concentration of the reactants involved in the reaction. On the basis of this rate law, an expression is being made which is known as rate equation or rate expression. This rate equation or rate expression is made on the basis of this rate law, which tells that rate of reaction is proportional to concentration of reactant raised to some power n, where this power n may or may not be equal to the stoichiometric coefficient of the reactant. This n may or may not be equal to stoichiometry coefficient.